Hello, everyone. My name is Garrett Polack. I'm a recent graduate from Georgia State University. My poster is titled Isolating Sources of Ionization in Nearby Seyfert Galaxies. So using APO's dual imaging spectrograph, along with HST's STIS data, I create visual representations of the dominant sources of ionization throughout these nearby Seyfert galaxies. My two targets shown here on this poster are NGC 1667 and NGC 4051. And the overall goal here is to study mass outflow rates of these galaxies, as well as determine the effectiveness of the AGN feedback on the rest of the host galaxy, including how it affects star formation in these isolated regions. And so to begin, I employ a statistical model to fit Gaussians to the emission lines taken from the APO DIS data. And so it separates these emission lines into separate kinematic components, specifically using the strong O3 emission lines. And so when I separate these into separate kinematic components, I can then take those parameters and fit the rest of the emission lines with the same number of components with some of the fixed parameters. And those will give me the emission lines that I need to create these BPT diagrams. So if we go down to these BPT overlays, we can see that I've taken the ratios of these emission lines and created these BPT diagrams, which tell us the dominant source of ionization for these kinematic components across the slits. And so for the two targets I have here, NGC 1667 and NGC 4051, you can see on the far left and far right the BPT diagrams, which show three separate regions of dominant ionizing sources. We either have the Seyfert, which shows the AGN ionization, the star-forming region, which shows mainly star-forming ionization, and the composite, which is a combination of both. And so for the three slits from APO for NGC 1667, you can see that they are overlaid onto HST images with accurate spatial scales to show that the AGN in red is usually found towards the center and sometimes farther out, as in the case of 4051. The blue indicates star forming regions and the green is composite or mixture of both. And so the results of this are that when you overlay these onto HST images, you see that they correspond pretty well to what we see visually. We see the blue overlapping the star forming regions, especially in the southwest of NGC 4051, and the red AGN regions are usually congregated towards the center of these galaxies. So in NGC 1667, you can see that the AGN outflow dominated ionization doesn't go too far from the nucleus. Whereas in 4051, you can see that it extends for a pretty good bit. So additional work is needed to compare these ionization maps with spatially resolved maps of the kinematics and outflow rates. And that's some of the things that our other group mates are doing. And I will be doing these similar analyses for an additional 6 Seyfert galaxies, comparing spatially resolved mass outflow rates with these local ionization mechanisms, and seeing how these AGN outflow regions are affected by the feedback from the central supermassive black hole compared to these regions where only star formation is seen.